So we're going to go over the angles of a polygon, review this. Now, for formulas, I'll give them first, then we'll do a proof of some of these. So, for any polygon whatsoever, the total interior angle measure is n minus 2 times 180. So if we've got a hexagon, all these angles, these are going to add up, the ones inside, to be n minus 2 times 180. 6 sides, n is 6, so we do 6 minus 2 times 180. If it were a rectangle, 4 sides, n equals 4. 4 minus 2 times 180. Decagon, n equals 10. You would do 10 minus 2 and get 8, and then 8 times 180. Hexagon, 6 minus 2, 4. 4 times 180 is what all these angles would add up to. You probably remember a rectangle is 360. 4 minus 2 is 2. 2 times 180 is 360. And sure enough, that's what they add up to. Total exterior is 360, interestingly enough. Remember the exterior angles for example, a triangle. We have a triangle. If we go around in one direction, extending the sides, these angles out here add up to 360. For a pentagon, same thing. One, two, three, 4, 5 exterior angles, and those 5 will add up to 360. That's the total exterior angle measure. Alright, make sure you got that copy down. Stop the video if you need to. Total interior is n minus 2 times 180. Total exterior is 360. So now let's look at when it's regular, and we can get individual angles. Now for regular, only, each interior, logically enough, is n minus 2 times 180 over n, where n is the number of sides. Because we had the total from before, we divide by how many angles we have, and that's what each angle would be. Since it's regular, so all the angles are the same. We divide the total into equal parts and see what each one is. So if we get a pentagon, and if all the angles were equal, we got 5 sides and 5 angles. So we do 5 minus 2 is 3. Multiply by 180 and get 540. And that's the total interior angle measure. All these add up to 540. Divide by how many angles you have? 5. 540 divided by 5 is 108. So each angle would be 108. Okay, each exterior is 360 over n. So if you want to know what an outside angle is, 360 divided by 5 would be 72. So this angle here would be 72 degrees. And that's a famous number found by some of our ancient Greek astronomers who were able to use basically that and a lot more to figure out the circumference of the Earth. Okay, if we had a square, 4 angles, 4 sides, 360 divided by 4 is 90. So each exterior angle is 90. Okay? Because it's regular, so they're all the same. Alright, so quickly, to get the total interior angle measure, no matter what kind of polygon we have, if we start at one, we want to find out what all these angles add up to. And if we divide the figure up into triangles, we've got, in each triangle, we've got a whole angle or part of an angle. But notice that they all add up to the total in the polygon. No more and no less. So we've got 3 triangles, and that's 2 less than the number of sides. So the number of sides minus 2 is how many triangles we have. And so we multiply the number of triangles by 180. And that'll be the total interior angle measure. Okay, now for exterior, let's take a pentagon. If we do the exterior angles, now if we have a dot at the center and we draw something parallel to this, they're the same. And then if we get this and draw it down, draw something parallel here, these will make the same angle as these because they're parallel to each other. Likewise here, this and this will make the same angle as this and that there. Then we can draw this one, draw a parallel to that, draw a parallel to this. And notice we've got 1, 2, 3, 4, 5 angles, just like 1, 2, 3, 4, 5. But these add up to what? 360. Since these angles are all equal, five here, 5 there, then we know that these add up to 360 as well. You can do the same idea on any size polygon, 4, 6, 8, 10, whatever. Each of these angles you can bring inside with parallel lines, and since the total adds up to 360, the outside add up to 360. Alright, cool. That's one more section done.